Hello guys, this is Yadikalsi again. Today we are actually going to work on really something special, which I'm really excited about. This is not considered a chapter, but a lot of you guys have requested to put some video for an RJ45 jack and related technologies around it, or related information around it. I am considering this to be like a miscellaneous topic, and I'm going to post like more and more videos, probably like short videos which explains everything around that hardware or a software or a technology, and we'll try to actually explain that in a best format I could or I can. So we'll start with the miscellaneous. So you will see these series coming up in the future videos as well. And we are going to call it demystifying something, right? So in this particular video, what we have done is, it's a miscellaneous topic, demystifying RJ45, registered jack 45. We are going to talk about the jack itself. We are going to talk about crossover and RJ45 patch cards, or crossover or patch cards over RJ45. And a very, very important topic these days is called PoE, or power over Ethernet. This is a technology in itself. There are certain standards, and we will touch more base on this PoE. This is actually more in line with the new networking technologies, or networking technologies in general. For example, home networks or small office network or enterprise class networks, where this power over Ethernet or more complex format of this technology is being used. So I'm glad that I'm here to explain all of that. So in this particular video, we are going to cover a couple of topics like I explained. We are going to cover in much more detail what is RJ45, what the jack in itself means, what are the standards of implementations with RJ45, the color coding mechanism or the color coding scheme which surrounds around crimping RJ45 patch cards and crossover cables. We are going to talk about patch cards, straight through cables, what is meant by a straight through cable and what is actually meant by a crossover cable. As told earlier, we will talk much more in details about power over Ethernet, and also the practical implementation of why all of these things and how all of these things are actually used, right? So the why is there and how is there, right? What is the need of basically using this technology, and how does it help us in the implementation, right? So let's start with that. I have given you a small tinker here. You see in the poly bag, I have something like a cable which is blue in color. I don't know if you guys can clearly see it. It says UL Underwriter Laboratories cable. It's a patch card. I will open this poly bag and I will cut the cables in front of you. I will show you what exactly we mean by that, so that you are absolutely clear about this RJ45 and the technology surrounding it. So let's talk about the very first topic, which is RJ45 jack standards and the color coding behind it. I will try to use different color of pens, but don't hold me onto it. So let's talk about the very first one, RJ45, which is registered jack 45. So what is this jack used for basically, right? So if you look at it, the jack actually is a 8-pin jack. It's also called 8P8C jack. There are 8 pins and 8 pins are connected. That's what actually it means in the simplistic terms, 8P8C jack. So there are total 8 pins in it. So I will right now I will not open it, but it looks like this. So this is the RJ45 jack. So let me explain what all of these 8 pins are there for, and if there is any standard behind it. So let's talk about the standard first. You need to actually remember this. It will really help you. It is TIA 568A or 568B. Most of the time we are using 568A these days, but I think it's from knowledge perspective of it, it is good for you guys to actually understand what is 568B also. So it's TIA 568A and 568B. The standard surrounds around RJ45, but it is correlated, right? So there is a jack, there is a color coding, and there is how you basically make a patch cord, or how do you basically use the jack to put the wires inside, and it explains everything. So this standard is about how to connect the wires using RJ45. So let's talk about the colors. So in a Cat5, so RJ45 we use Cat cables. In the other topics in the chapter 3 and 4 we have covered that cable could be Cat3, could be Cat5, could be Cat5e, could be 6 and 6e as per today's standards. So what is Cat3, Cat5, Cat5e, Cat6e? You guys should know about it by this time. So there are total 8 wires in it, 8P, 8C, right? So there are total 8 wires or 8 conductors. And we call it 4 pairs, right? So let's do that. What are these 8 pairs? So there are colors, 4 type of colors which are used: green, orange, blue, and brown. First color, second color, 3 color, 4 color, right? So what is the other color? The 1A color is actually white green. 2A is white orange. 3A is white blue, and 4A is white brown. I was trying to actually explain this. So the green cable is like this. Solid green cable will look like this, but the other one, the white green, is green white, green white, green white, green white. So this particular color is actually white, but let's just for the sake of example, let's do it like this. So this black is actually white. So this is a solid green, and this is white green. That's how actually it makes one pair. The other one is orange. We are going to represent orange with red. So it is red, and then dash 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 means white red, right? Same thing is true with the blue. Let's use the blue cable. Then we have white blue, and then in the last we have brown. So we are going to represent it with a black. So we have black, and then we have brown and white, brown, white, white, brown. So this is first pair, this is second pair, this is third pair, this is the fourth pair. This is how you actually identify the pairs in the category 5 cables. Now these cables are inserted, these 4 pairs are inserted into the RJ45 jack. So let's talk about what exactly RJ45 jack is and what are the pin configurations for the standards. I will use a black pen, and I will try to make it little bigger so that you guys can understand. So this is 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So there are total 8 what? Pins. 1 pin, 2 pin, 3 pin, 4 pin, 5 pin, 6 pin, 7 pin, 8 pins. So there are total 8 pins in that. And this is the latch underneath that. So I'm trying to look towards the connector from right in front of me, right? So we are going to talk about, so let's, for the time being, let's leave the cables aside. Let's talk about the pins of this one, right? So there are total 8 pins, and in the Cat5 we have total 8 what? Connectors, which is 8 wires. So obviously these 8 wires are going to go somewhere. That somewhere will be decided by 568A or B standard. We are going to talk about both of the standards today, okay? So let's talk about T568 standard first. T568A, which is TIA standard, right? So we have total 4 pairs, right? So the first pair is like this, the second pair is here, the third pair is between this and this, and there's a pair like this, right? But we name it differently. So here we call it pair number 1, P1, pair number 2, P2, then we have pair number 3, and we have pair number 4. Again, between 4 and 5, between 3 and 6, between 1 and 2, and 7 and 8. So these are connected like this, right? So this is TIA 568 standard. This you guys need to know inside out. So what in 568A standard, there is a standard of the cables, how we are going to actually put the cables also. So let's use different color pens. So the first one would be green, white. The second will be green. The third one will be orange, white. Orange, white. Then we have blue, solid blue. Then we have blue, white. Then we have brown, orange, solid orange. Then we have brown, white, and we have solid brown. So I will just say white, green, then green, white, orange, blue, white, blue, orange, white, brown, and then brown. So 1, 2, 3, 4, 5, 6, 7, 8. This is how the cables are actually connected in a 568A configuration. So pair number 1 is between blue and white blue, right? You should be clear by now. Pair number 2 is white, orange and orange, like this. Pair number 3 is white, green and green. And pair number 4 is white, brown and brown. Absolutely clear. Make sure that you're absolutely clear. You can actually rewind the video in order to understand this 568A standard. This is how the standard is about, not the pins, it's that the standard is about how the color coding is actually used. And I will try to explain when we explain more with the colors, when we are going to make a crossover cable or a patch cord using these colors. So let's talk about 568B standard. T568B as in boy. We are going to make this thing again. Because it's RJ45 jack, we have 4 pins, 8 pins. 1, 2, 3, 4, 5, 6, 7, 8. The same thing will happen. Pair 1, P1, pair 2, pair 3, pair 4. But what is going to change? We have 8 connections and 8 wires. We have 4 pairs, 8P8C, right? Here in the very first one, we have orange, white, orange, green, white. If I can find my pen somewhere. Okay, I got it. Green, white. Then we have blue. Then we have blue, white. Then we have solid green. And again the same norm we were saying, brown, white and brown. Let's name them. White, orange, orange, white, green, blue, white, blue, green, white, brown and brown. So pair number 1 is between blue and white blue, white, green and green, white, orange and orange, and white, brown and brown. What is this standard? This is called T568B standard. So if you look at the cable which is here, you cut the cables. So if and looking from the front, if the cables are connected like this, it means it's a 568B standard wire. I think hopefully this is clear to you guys. Before we go any further, let me try to show you this particular thing. So this is also called a patch cord, right? It will come in an envelope like this, or a plastic cover like this. It might have some information like who actually made it. It normally will say communication circuit accessories and so on and so forth. Nothing fancy about it. You just open it. Here, this is a cable, right? Let's open it real quick. I don't want to put too much of emphasis on it. You guys will have practical experiences. So this is nothing but a patch cord, right? Patch cord is, we have two RJ45 jacks here, and we have a cable, right? So it has two connections. This is basically a latch here, if you guys can clearly see it. This latch actually, when you put this into a computer, like this, if you put it into a computer, the latch actually goes and covers it so that you cannot accidentally pull this cable out. So in order to do that, you have to press it like this, and the latch actually goes inside, and then you can actually take it out. So it's a more secured cable. It's it's little expensive than the regular cables. And there is a reason for it. If you see, the quality of the cable is quite good. This is on category 5 E cable. And you will have certain markings. I don't know if you guys are able to see it or not. You have a markings on the cable, and through that you can actually see if it's a Cat 5 or a 5E or 6 cable, right? Here, if you guys see it, we have orange, white and orange as the first pair to it. So what does it mean? It means that we have a T568B standard cable here, right? Just put it like this, and you will know what it means, right? When I was saying it, it goes from left to the right. Let me show you where are those cables. So I will just cut it like this. And here you can see all of those 4 pairs we have been talking about, right? So this is what I showed you guys was like this. I don't know if you can clearly see it, but this is white, orange. This particular cable is white, orange. This is orange. This is green, white, and this one is twisted together. That's why it's called twisted pair. If you look at this, we have white, green, a little shade of green and a white, and a solid green, right? Then we have blue, like this, blue, white. There is a little shade of blue and white, and there is a solid blue. And here you have the brown cable. It's called brown, white, and brown, right? So if you try to put this in this particular fashion, what you need to do is, you'll put it white, orange, orange, white, orange, orange, white, green, blue, white, green, blue, right? Then white, blue, green, then white, blue, and then green, then white, brown, and brown, right? If you look at this, this is what I actually meant by that standard. If you look carefully, it has to be done like this, right? So we have orange, white, orange, white, green, white, green, blue, white, blue, green, white, brown, and brown, right? This is how it will be. This is not the right tool, but there is a crimping tool. If you can cut it like this at the end of the day, and you will use the jack, this RJ45 jack, and you will basically insert that into that and use a crimping tool to crimp it. So that crimping will be according to the 568B standard. And if you go to the previous slide, or if you scroll back, if you rewind this video, that other standard we were talking about, which is green, white, green. So let's talk about 568A. 568A standard stands for, we have white, green, then green, then we have white, orange, white, orange, white, orange, blue, blue, white, orange, white, brown, and brown, like this. I don't know if you guys are able to clearly see it, but it will be T568A standard. So this is how it basically looks like. Now we are going to talk about using the same thing. I think you guys are clear about these wires now. How to make how a standard patch cable looks like, or how a crossover cable looks like, and how we will do what exactly is the pin configurations behind it, right? So we talked about 568A standard, 568B standard. Now we are going to talk about how this patch system or patch cord system actually works. I'm just trying to save my pens from drying out. So let's talk about, we are now, from now onward, we are going to talk about 568A standard only. So we have a jack, right? We have another jack, RJ45 here. RJ45, RJ45. So if you guys pay attention a little bit, I just cut this cord, but this is what I mean by that. Okay, RJ45 and RJ45. So what goes in between is what is in the wire itself, right? So how we will know that this is a straight wire or a patch cord, right? So this is what we are going to explain. So when I say RJ45, it means this RJ45 is here and RJ45 is here. Okay, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. We have to name it 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, right? So the first wire, as per that one, was white, green, right? White, green, green, or sorry, white, orange, blue, white, blue, orange, white, brown, and brown, right? So white, green, green, white, orange, blue, white, blue, orange, white, brown, and brown. So what is the straight over cable? The straight over cable is simple. White, green means green, orange, white, orange, blue, white, blue, white, orange, orange, brown, white, brown, and brown. So when point number 1 is connected to the point number 2 on the other RJ45 jack, it is actually called a straight cable. Straight cable. Okay. Pin 2 is connected to pin 2, pin 3 is connected to pin 3, pin 4 is connected to 4, 5, 6, 7, they are straight connected. So that's why it's called a straight cable. What is a crossover cable? Before we go there, I need to actually tell you, it is getting more complicated, but you guys need to actually understand. what is the meaning of all of these things. We are going to make one more section here. And we are going to talk about some more details about the transmissions. Transmission. So these pins actually send and receive data, and some of the pins are actually not connected. So which pins are not connected and which pins actually send the data is important to understand, right? So the very first pin, and there is a difference between types of connectivities and how the data is actually transmitted. So I will just 10 base T, 100 base T and 1000 base T. So we are going to talk about these two standards, and then we are going to talk about 1 gig standard. So there is something different between 10 base T and 100 base T, 100 Mbps networks, 10 and 100 base T networks, 10 Mbps and 100 Mbps networks, and gigabit Ethernet. So there is something different here, and I'm going to explain what is different here, right? So the very first pin is actually called TD plus, or sometimes you will see in the books called TX plus, transmission plus. Sometimes you will see it TD minus, or we can say TD minus, TX minus. This is RD plus, or we can also say RX positive or plus. 4 is NC, NC. 4 and 5 is NC and NC. Here we call it minus RD or RD minus or RX minus. I will explain all of these terms to you. And this is NC and this is NC. NC means not connect. NC is not connect, NC is not connect, NC is not connect, NC is not connect. And same is true here, right? So here we are going to call this TX positive, TX minus, RX positive, NC, NC, RX minus, NC and NC. So these are the pin numbers or pin configurations, how they are actually put together. So here in this case, if somebody asks you, it could be exam question, so just be prepared with it. How many wires are used in 10 base T and 100 base T in order to actually transmit the data? So the answer is 4 wires. Why? Because pin number 1, 2, 3, 6 is actually used. So let me write it. 1, 2, 3 and 6 is actually used. Whereas 4, 5, 7, 8 is not connect, means not in use. So 4, 5, 7, it is not used, but 1, 2, 3, 6 cable is actually used to transmit and receive the data over the networks. So before we go any further, there could be a question that what type of data could be transmitted over this? It's a very general, it's a common sense question actually. People might get confused with it. You can use this network, RJ45 Ethernet networks, actually Ethernet networks, to transmit data, voice and video, all 3 of them. So let me explain it to you. Data, voice and video, all 3 of them can be transmitted over this particular configuration, which means by data means it could be internet browsing. VoIP, voice over IP is actually voice, which could also be transmitted, and also video. It could be like camera video, it could be like YouTube, means anything which is related to the video can be transmitted over the same configurations. But keep it in mind that is this 10 base T and 100 base T. We are specifically talking about 100 Mbps networks. 100 Mbps networks, because the configuration for 1000 BT is little different than 100 base T networks. So if you think about it, very important, and I have learned through this my experience. You guys could actually ask this question, that why we have two almost like similar transmissions, like TX plus and TX minus. Then we have RX plus and RX minus. Then obviously we have not connected, right? NC, not connected. So why we are using two? Why we cannot use TX and RX only, transmissions and receive, right? So we use two pins to do the transmission, and we use two pins to receive the transmission. So there is a logic. I don't know how, but I will try to actually cover this. It's actually very nicely. It's nicely done. Let's try to cover that particular piece. So what exactly happens? I'm just trying to make it less complicated. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 7, 8. 7, 8. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Four, 5, 7, 8 is not connected, and we are using 1, 2, 3, and 6, right? So this is TX positive, TX minus, RX positive, RX minus, NC, NC, right? Like this. So what happens is, imagine that on a wire. So how the transmission actually happens? So this is a wire. What happens is, when the data is sent from one direction, just from the basic understanding of it, the current actually flows through this wire and actually creates an electromagnetic field around the wire, right? Like this. So now imagine that you have another wire which is just next to it. In this example, we have seen how close are these wires, right? And they are twisted together. So I'm talking about these two wires, maybe like white, blue, and blue, right? So these are the two wires like this, right? So now imagine the other wire also has electromagnetic field around it, right? Don't you think that they will be cancelling each other? The answer is yes, they will be cancelling each other and they will be creating a lot of noise. So what happens is, the technology, when you say TX positive, it actually means the signal is traveling. This is positive and minus, right? On a graph. So what happens is, the TX positive means the T transmission is only happening on the positive side of it. When TX minus, the transmission is actually happening on like this. So let's say 1, 2, 3, and 4, and 1, 2, 3, and 4. If you look at both of these charts, they are mirror images of each other. So if I have to put a single chart for this one, I might have done something like this, right? So 1 dash, 2 dash, 3 dash, 4 dash. So this is an exact mirror image of this one, and this is how the transmission actually happens in the real world, so that the less noise or less interference is actually created. One is a positive signal and the other one is a negative signal, and they actually compensate each other. That is what called the mirroring of the signal. So that's why it's called TX positive, and one is called TX negative. So this is how the signal is basically transmitted here. The same is actually true with the receive. This is sending and this one is actually receiving. So when you receive the signal, it is going to happen the same way, right? You can put positive and minus here. This is traveling in this direction and this is traveling in that direction, right? So that is what the significance is, and that is what the reason that we use TX positive and we use TX minus. We use RX positive and we use RX minus in order to cancel the EMI, electromagnetic interference, between both of the wires when the signal is traveling through them. Now we have to talk about NC and NC. You guys could have said, hey, if we are only using like 4 wires here, 1, 2, 3, 4, why the need of actually creating 4 more wires? Like we could have saved some cost and we could have done something else. So we are going to touch that topic in something called PoE. That was well thought out standard for category 5E, 6E category 3 cables. So there must be some reason that they have put 8 wires there. And why they have put 8 wires, we are going to actually cover in the PoE topic. hopefully this is clear. This is actually not true. This is only true for 100 base and 10 base T networks. In the 1000 or 1 gig connections, the technology is the same, but the pin configurations are not the same. So what are the pin configurations? Let's go through that. Let's go to the pin configuration of Gigabit Ethernet networks. So here I will pick up a pen and we are going to talk about 1000 base T networks, which is 1 gig. So the difference is, again, the pins are the same because the jack is the same. We are using RJ45 at both of the places. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Right? So once again, in 10 BT and 100 BT, only 4 wires are used to transmit and receive the data. The remaining 4 are NC, not connected, but they are used for different purposes. But for the 1000 BT network or 1 GB network, we use all pins. All connections are used to transmit and receive the data. Make sure that you understand this thing very clearly. Absolutely clearly. So 10 BT, 100 BT networks, we use 4 wires only to transmit and receive the data. 4 are not connected. In the 1000 BT network, 1 gig network, all of these pin configurations are used. And I'm going to explain you what these connections are actually used for. So going back to the same thing, in the EIA, TIA, T568A standard, the color coding will remain the same. So I'm not going to go there again, but I'm going to explain something else to you guys here. So what is this cable? This is a straight cable, straight patch cord. So the first one is white, green, white, orange, blue, white, blue, orange, white, brown, and brown. So if you look at this, the color scheme is the same, right? We did not change the color scheme. But what we call them, these pins, is actually a little different. What these pins are called, right? So these pins are basically called so there is something. So what we are going to do is, because there are total 4 pairs, PAIRS, total 4 pairs, we are going to call them A pair, B pair, C pair, and D pair. Okay, that way it is easy to remember. So when I call DA, it means data for pair A. When I call DB, it's data for pair B. DC is data for pair C, and DD means fourth data for pair D, right? So BI stands for bidirectional communication. So BI positive, the first pin, BI positive for DA. It's a little complicated, but just follow me what I'm trying to say. Then BI negative for pair DA, bidirectional communication. BI positive for DB, and we are talking about 1 gig networks, 1 gig patch cards. Then we have BI minus positive for DC, BI negative for DC, BI negative for DB, BI positive for DD, and BI negative for DD. That's how it is. It looks complicated when I make it, but I will try to explain it to you how it becomes simple, right? So here the DD pair is the same, the AA pair is the same, the B pair is like this, and the C pair is like this, right? So first pair, second pair, third pair, fourth pair. But how we are going to call it? We are going to call it differently like this, right? We are going to pair 1, 2, 3, and 4, right? If you look at, if you remember the other one, I'm just going to make it small here, right? We made the jacks like this. We are saying pair 1, pair 2, pair 3, pair 4 like this, right? So that's what the same thing I did here. Pair 1, pair 2, pair 3, and pair 4, right? Hopefully this is clear. It is for 1000 base T, 1 gig networks. Absolutely, you have to be clear because it is very different than 100 base T, 100 Mbps networks. And we are going to cover a PoE over this 1000 base T networks also, which becomes further more complicated. We have talked about the straight cables because pin 1 is connected to pin 1, pin 2 is pin 2, pin 3, pin 3, pin 3, pin 4, pin 4. So all of them are connected, so that's why they are called the straight cables, right? So we have talked about straight cables for 100 Mbps networks and 1000 Mbps networks. We are going to talk about crossovers. We have already talked about the jacks, the standards. We are now talking about crossover cables, right? Crossover cable. So what is meant by a crossover cable? 1, 2, 3, 4, 5, 6, 7, 8. That's a standard now. You guys should remember 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. Okay guys, let's start talking about the crossover cables. We talked about, just now we talked about the straight cables or straight patch cables. It doesn't mean that it's only a patch cord. The straight is a configuration basically. Straight cabling is a configuration. So what I mean by that is, real quick, we have an outlet jack here and we have some sort of structured cabling rack. For example, we have 66 block, punch block, and then we have a patch panel here, right, with the RJ45 jacks here. And then from the jack we have a networking switch here. So we run a cable from here to the networking switch, and from the outlet, RJ45, these are actually punched here. So this could be a straight configuration as well, straight configuration or a crossover configuration. So this is what I mean by that. And the patch cord was RJ45, and you have a straight cable. That's what we were talking a few minutes back. So let's talk about crossover cables, and all of the configuration for crossover cables for T568A and T568B is the same, because the pin configuration is what it matters. The color of the cable will define whether it's a 568A or 568B. So let's quickly go over this pin configuration again. Here we have 8 pins, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, and 8. Right? So here what we know is what is used and what is not being used. So we know for sure that 7 and 6 is not for used. 1, 2, 3, 6 is only used for the data connections, and the remaining 4, 5, 6, and 8, 4, 5, 7, and 8 is not used. It's NC, right? And the configuration is TX, transmission plus, transmission minus, RD positive, RD minus, RT minus, and this is NC, 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 NC. So the same is actually true here. So we will say TX positive, TX minus, RX positive, NC, NC, RX minus, NC, and NC. This is what you need to understand, because just few minutes back I was trying to explain why these TX is 2 sets and why this RX is actually 2 sets. We will talk about power over Ethernet for these NC connections, because these NC connections are actually used to transmit the power over the Ethernet. That's why it's called PoE. So let's talk about the crossover cables, right? Crossover cabling. So it's not very complicated. Just for the simplicity, all you need to remember is the pin configuration, right? So it's actually, the pin configuration is 1, 3, 2 and 6. 1, 3, 2 and 6. This is the number you need to actually remember in order to make a crossover cable, or to verify that it's a crossover cable configuration. So what do we mean by that is 1, 3, 2 and 6. 1 goes to 3 and 2 goes to 6. That's what actually it means. The remaining everything else remains straight. So here from A to B, this is RJ45 jacks. Once again, I will keep reminding you guys. It's very, very important. So 1 goes to 3 and 2 goes to 6. So what will happen on the other side? 1 will go to the 3 and 2 will go to 6. That's all the crossover cabling configuration is. So what is remaining now? 4, 5, 7, 8 is remaining. So 4 goes to 4, 5 goes to 5, 7 goes to 7, 8 goes to 8. So when you cross the cables like that, at that point it means that it's a crossover cable configuration. So okay, if you look at guys, you need to pay attention on what exactly. So this is what we were talking about. So you need to pay a close attention to these TX positive, TX negative, RX positive and RX negative, because something happens here. The remaining is just a physical connect or a physical configuration, but this is more in the technical details of what exactly happens, and you need to understand that. So here and here also, right? So let me explain what is actually happening. So if you pay close attention, actually the TX positive is getting mixed up with RX positive. So the TX positive communication is actually going to RX positive here, and the TX negative is actually going to RX negative from A to B. Okay, then B to A is the same thing, right? So TX positive is actually going to RX positive here, if you look at this cable, and TX negative is actually going to RX negative. So this is the crossover cable configuration. So let me redo that. You guys should know what happens in the straight over cable then. So in the straight over cable from A to B, straight over cables, TX positive goes to what? TX positive. TX minus goes to TX minus. RX positive goes to RX positive. RX negative actually goes to RX minus. This is what the straight over cable configuration is. This is not related to anything related to the exam, but this is a little bit more in detail. But you will actually understand if you talk to somebody. You will feel like much better that you know the technical details of the crossover configurations and the straight over configurations now. Let's jump on to the other very interesting topic, which is power over Ethernet. And you guys will actually see this word traveling across PoE, power over Ethernet, and so on and so forth. So what exactly power over Ethernet actually means, right? So we will try to cover this topic, power over Ethernet, right? So in the OSI layer, I don't know if I should mention it here. It's called Open System Interconnect. So this is the 7-layer architecture where Ethernet as a protocol stands at layer 2. So what it means is, so when we actually build up the networks, there are three type of segments, right? Three type of layers going from south to the north. We call the physical layer, then there is a layer 2 logical layer, and the third one is a layer 3 layer, like logical layer. So Ethernet actually is residing at, or it is sitting at layer 2 of it. 1, 2, 3, and there are 7 layers of it, right? So one is the physical part of it. So whenever we do any pin configuration or crimping or anything of physical connectivity, that comes under the physical portion of it, like the physical connectivity of the networks. So how do we make the power to transfer over Ethernet, and what was the need of it, right? So first we need to understand why did this thing happen. So here is the problem statement. I will try to tell you. We have a network switch. If you go to Best Buy or Fry's or anybody, anywhere you want to order over the Amazon or something, just say like a simple network switch, right? It has, let's assume that it has 5 ports, total 5 ports, right? And we have an access point here somewhere, AP for the wireless, access point for the wireless, right? And you guys must have, by these days, everybody has a router which is Wi-Fi enabled, which is being provided by the ISP or the access providers. So if you see, there are actually 2 type of wires which actually goes into it, right? One is a power cable, right? And the other one is the data cable, which is now Cat5e cable we are going to talk about, right? So there are 2 set of cables, 1 cable, 2 cable. This normally provides either 12 volt or 48 volts or something of 48 volt DC current into the access point, so that this system actually boots up and then the data is actually transferred over the data cable. Now from the network switch, this particular cable actually will be connected to the network switch, right? But what will happen to the power? So the idea is you have 2 cables hanging off this access point. So the IEEE Institute for Electrical and Electronics Engineers, they thought of actually a standard where they actually want to transfer the power over this particular data cable itself. So that particular standard was actually developed around I think 2003 time frame, and it is called IEEE 802.3AF. IEEE 802.3AF, like Apple and Frank. So this is what the standard is for the PoE, developed around 2003 by IEEE people, right? So IEEE is basically a consortium, or it's a set of bodies or multiple institutions, or it could be institutions and individuals who are like experts in the field. They get together on a table and they decide that, okay, in order to have a worldwide standard, we need to actually document it in such a way, like for example, 802.3F dictates the PoE standard, and this has been actually grown over a period of time. Cisco was the first company who actually came up with its own version of providing power over Ethernet, but it's a non-standard configuration. Means the PoE of Cisco won't work with any other device in the networking infrastructure. So if you buy Cisco, you need to actually buy only Cisco. So Cisco won't operate with Avaya, Cisco won't operate with Proxim, Cisco won't operate with Aruba Wireless or something of that nature. So that was the problem statement, and that is the reason that this standard was actually developed. So what we are trying to discuss here is what was the problem statement, what we were trying to actually solve by putting the power over the Ethernet. So this is the problem statement, right? So the people think that why we need to actually put a power and data wherever the data cable is already going. And if you guys remember, we have actually 4 set of cables, individual cables, which are in NC mode. So which are not even connected in a data cable here, right? So 1, 3, 2, 6 is connected, but the remaining 4, 5, 7 and 8 is actually not connected. So they were trying to use this 4, 5, 7, 8 pin configuration in order to provide power to this device. So that was the problem statement and the solution behind it. But how does actually it works, right? Very, very important to understand. It might not be related to the exam, but it's always good to know when you look at the jack, when you are trying to troubleshoot. So if you know more, it always helps you to reach to a point, a troubleshooting point, rather more easily, right? So let's talk about what are the components of a power over Ethernet network, right? So there are components of it. PoE, what constitutes actually PoE? So in the PoE, we have basically mainly two things which we normally talk about. One is called the power sourcing equipment. One is called the power sourcing equipment, PSE, and the second one is PD, right? Powering device or powered device, basically, that's what it means, right? So from the language, it is not that complicated. PSE will be the equipment which will be actually providing the power, and powered device is a device which gets powered. So here in case, in the previous example, we can say the networking switch was the PSE and the PD was the access point, the wireless access point, right? That's all it is to, and I will explain how this pin configuration actually works on RJ45 Cat6 maybe patch card. That could be a good example to talk about. So I will make a little complicated diagram. Just bear with me. That is helpful for you guys to understand. And before even we go there, we need to actually understand, or we need to know, like I have been telling in the previous few minutes, that there is a difference between 10BT, which we are actually not going to talk about now at all, because there is no 10 Mbps networks. We will say 100 Mbps networks and 1000 Mbps networks. Only these are gig networks, right? So like I was explaining last time, that 100 Mbps network configuration is little different than the 1000 base Mbps connection from the pin configuration standpoint of view. So obviously the PoE also gets affected out of it, how the PoE is getting transferred for 100 Mbps connections, and how the PoE is actually getting transferred over 1 gig of connections, right? So they are also called alternative A and alternative B. So here we actually call it alternate, ELTER, alternate A configuration, and here we call it alternate B configuration, right? So for the simplicity, let's talk about 100 Mbps connection first, and then we will talk about the 1000 Mbps power over Ethernet configurations. So 100 Mbps PoE, right? We need to quickly draw what exactly, this time we are going to draw a little more bigger boxes, because you need to understand the intricacies of what is actually happening inside the wires, right? So we will draw total 8, and I'm going to like little bit do it little differently here for a obvious reason, like this, right? So I'm just trying to draw these pins a little closer so that I can explain it to you what happens in an alternate A configuration for 100 Mbps connections. And here we are talking about 1, 2, 3, 6 is connected, and 4, 5, 7, 8 is not connected. So we just pay attention to that, right? So, and there is configuration called TX plus, TX minus, this is RX plus and RX minus. It's very, very important for you guys to actually understand, because these are the these are the 4 wires we are going to use here to transmit the data, and the remaining 4 wires we are actually going to transfer the PoE over the link. So before I go to what PoE actually is, what voltage type is actually supported over it. So you need to understand that in a PoE configuration, the PSE sources up to 12 watt at 48 volts to the each PD. So it's actually at 12 watts at 48 volts to each PD, means each access point or each endpoint device, we can say. So this is very, very important for you to understand. Mug it, remember it, that this is what the configuration is. So let's talk about the alternative B configuration here. So as you know, we will go from south to the north. We will say this is pin number 1, this is pin number 2, this is pin number 3, this is pin number 6, this is pin number 4, pin number 5, pin number 7, and pin number 8, right? So 4, 5, 7, 8, 4, 5, 7, 8, 1, 2, 1, 2, 3, 6, 3, 6, right? So the 3, 6 is basically used for what? It is used as Rx positive and Rx minus. So Tx positive and Tx minus, right? So we can say here that it is I don't want to draw it here, but let's say this is Tx, just for the reminder, and this is Rx, and this is NC, right? NC positive and NC negative, right? So I can say positive, negative, which is Rx positive, negative, and Tx positive, negative, and this is NC positive, NC negative, right? So what happens in the background? So I will just do the same thing. Rx, Tx, minus, plus, 4, 5, 1, 2, 7, 8, 3, and 6, right? So we talked about in this in the previous minutes that how the data is actually transmitted by using two of these positive and the negative, right? If you guys remember, just as a reminder, that the positive was like this and the negative was exactly the mirror image of this, right? So that is the reason, and we are going to show it differently here, right? So what happens is there is something which happens inside, which we will explain it later, and which something happens outside, right? So from point number this one, there is actually a connection like this, and there's a connection like this, there's a connection like this, there's a connection like this, right? This one we are going to do it like this for a reason, okay? So which means the same thing, like it's a mirror image of the same thing, right? So positive, negative, right? Here also we are going to do the same thing, like that. So which is Rx positive minus, and this is Tx positive negative. What about this one? This doesn't happen. 7 goes to 7, 8 goes to 8, 4 goes to 4, 5 goes to 5. So what happens here is there is actually, here is a DC supplier. It's a DC, if you call it PSC, power sourcing equipment, and this is power device. So this will actually provide 12 volts, 48 volts to that particular link. So the power actually goes in here and it gets, you have DC to the DC converter, and basically the link goes from here. The remaining other, this one, this one, this one, and this one is connected to the data pair. Very, very important for you guys to understand. I will just repeat what I just said. So we can say that this particular concept of power over Ethernet is for 100 Mbps power over Ethernet alternative B configuration, alt B configuration. So in alt B configuration, the PSC, power sourcing equipment, is actually providing 12 watt 48 volts to each powered device. Each powered device could be a phone, a voice over IP phone, it could be a regular phone, it could be an access point, and more things are actually coming up in the market which needs to be powered through the PoE itself. But a very good example I'm going to cover in the future also is using the access point. So this is the power device. So in this configuration, just repeating once again, we have total 8 pins, and this is a RJ45 jack. So don't get surprised with what we just built out here. That looks so complicated, right? So this is RJ45 jack with total 8 pins, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. But I have named them differently in order to actually put this diagram in perspective so that you guys can actually understand what is happening where. So pin number 1 and 2 is actually doing a transmission. So I am just showing this, that transmission is happening between two wires, using two wires. Here the receive is happening between two of the devices using this particular type of representation. And this is the major topic we were trying to cover here, power over Ethernet. The DC 12 watt 48 volt is supplied from within the device. It's not, this is the jack, but it is actually, if you guys remember, this particular jack is again connected to something outside, right? So that DC power is supplied on the positive here on the two wires and negative here on the two wires, like this. And when it gets connected to the PD, the access point, it gets actually dropped out, and this system actually gets powered, and the data is actually transferred over the data pairs. Hopefully this thing is actually clear. If you have any questions on this, please do let me know. I'm sure you'll have, because it's a little complicated than normally the exam would actually ask. But this is not related to the exam. This is for we are just basically building up a base in order to understand the future with the networking technologies. Also, this, once you understand, this will help you really work with the networking industry. And these are very common things which are actually used in the networking infrastructures. Let's talk about 1000 Mbps alternate A configuration, right? As you guys understand that the alternate A configuration is very different than the regular 100 Mbps connection. So we are going to build the same thing, and we are going to talk about a more complicated term here. So in the alternate B configuration, what happens is, let's draw the same thing, probably 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, right? So here 1, 2, 3, 6, 3, 6, 1, 2. And this particular thing is NC. This is called the alternate A configuration. So the same thing will happen. Let's draw this line. Right. I actually want to point out that why I said it was 1000 Mbps connection, because of the technology called phantom feeding. It's called PHANTOM feeding. Phantom feeding. So what does phantom feeding means? That we do not use separate wires in order to transfer the PoE, the power, but we use the same TX and RX cables in order to actually transmit the power over to the PDs. This is PSE, power sourcing equipment, and this is power device. So now, if you guys remember, we have total 8 wires in the RJ45 jack, and all of the 8 wires in a 1000 Mbps connection are actually used, right? So all of these wires are actually connected. So how do you transfer the power over that, right? Because we don't have any wires which are actually left. Like for example, going just back 1, 2, 3, and 6, 4, 5, 7, and 8 are actually NC, but here in the 1000 Mbps connection, all of the wires are actually connected. So how will you transfer the power over over this link, right? So the idea is like this, right? It's called phantom feeding. It's not an exam question, but so what happens is, this is a DC provider. Okay guys, I think we lost the video somewhere. Right. So what happens is, the DC actually is provided to this particular segment. To a conclusion on it. So we were talking about PoE, power over Ethernet, our alternate A configuration. So this is again an RJ45 jack, right? We talked about that the power is actually transmitted over the data pairs itself. So these are the data pairs, and we don't have a separate power cables going from point A to point B between two RJ45 jacks. So this is PSE, power sourcing equipment, and this is power device. So here the power is actually given to this device. This power is actually transferred to the data pairs itself. On the other end, this power is actually converted, not converted, is actually it's fed into a box or a device. It's not relevant here, and this is used to actually power the device like an access point here. Hopefully this is clear. Please do ask questions if you have questions on it, and I can try actually explaining it more probably in the other upcoming videos. For now, this is I think good enough for the power over Ethernet connections. Let's go to the next topic where we are talking about making sense of it all. Where all of these things will actually come together. I want you to understand why we are talking about these power over Ethernet, RJ45, color coding, and this and that, and how it actually makes sense in the field to us. So what we are going to do is we can say making sense of it all, or we can say practical implementations. You will learn something new here as well. So we are going to talk about RJ45. We are going to talk about state cables, crossover cables, CX cables, and we are going to talk about power over Ethernet. These three topics, right? So, and this is more relevant or more in line with today's computer networks. So you will understand more, and you might say aha moments also, that aha, I knew that, or now I know how all of this thing actually happens, right? So in the diagrams also, we start learning these things, that this is actually a cloud, which is normally represented, you can say MPLS cloud or internet cloud or anything of that matter as such, right? So there is an internet connection, and we are talking about home networks here, right? Home networks specifically. So there is an internet connection coming from Time Warner, AT&T, Verizon, anybody you want to call. There will be a connection coming in, and there will be a router here. So the router is represented like that, right? And then the router will be connected to a switch. Let's assume that we have another switch, two switches. We have a computer connected here, something connected here, something connected here, and we have something connected here, and we have something here, right? And I will tell you what exactly. So this is the laptop 1, this is computer 1, this is computer 2, this is network switch 1, network switch 2, this is access point 1, wireless access point, and access point 2, okay? So this goes here, this goes here, this goes here, this goes here, and this is wireless connectivity. This is also wireless connectivity. So this is how actually it's represented in the diagram. And I'm going to deliberately make it a different link from here to here for you to actually explain what these cables are, right? So let's talk about the RJ45 jacks first. So you guys should know by this time that this is RJ45, this is RJ45, this is RJ45, this is RJ45, this is in fact RJ45, 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 right? So these many number of RJ45 jacks are there. Now, what type of cable is this? This is a straight cable. So understand that from computer to the switch is always a straight cable. This is also a straight cable. This is also I will just leave it for further discussions. This is a straight cable. This is a straight cable. So there is a good chance that if you are talking as of today, which is 2016 September, that these cables are straight cables. But if you are talking about 5 or 6 years back, probably more than that, there is a very good possibility that these were crossover cables. So why this happened? Because over a period of time, the manufacturers of these routers, the switches, they realized that it is actually adding a more piece of confusion when the people are actually installing that, and it was definitely there is a cause of more support calls, because you will tell, hey, I have connected my router to the switch and it is not coming up, the lights are not coming up, or the connectivity is not there. But you will realize that the connectivity was not there because of the cable type you might have used. So now also, if you are working with a little old equipment, you can always try, if you are doing a direct connection, you can always try putting a crossover cable if the straight cable is not working, or vice versa, right? So between the network equipment, it's always a crossover cable as a standard you can think of, but you should first attempt to put a direct cable first, and most probably it will actually work, because all of the networking equipment is something called in an auto negotiation mode these days. So it's called auto negotiation mode. What means that they can actually see if the straight cable is not working, then they will actually put the connections automatically into a crossover pattern. And what is a crossover cable and what are those crossover patterns we have covered in the previous chapters. So we have covered RJ45, this RJ45 where the RJ45 users do. Straight cables we have used, crossover cables we have used. Let's talk about power over Ethernet here for a moment. So here the access points with the wireless access points, I have only dropped one cable here for a deliberate reason, right? So I wanted to actually tell you that this particular straight cable on a 100 Mbps link, just to keep it simple, is using data plus PoE over the same wire. So the power is actually transferred to this device in order for this to power up over the same cable. So what it is providing, 12 watt 48 volt DC to power this device. How would you know about it? All the devices, they have switches, they have ports. You will see RJ45 ports mentioned PoE, right? In the PD and PSC, both of them. PSC is a switch, so it will say the PoE switch is there. So, and in the PDs also, they will say that PoE, so that you're not getting confused. You're not plugging this cable into the wrong ports for them to actually boot up, right? So if you go to the market these days, you can always say, hey, I need a PoE switch. If you need it, it means that you're planning to power something off that switch itself, right? If you are not using a PoE switch, it means you can actually always, most of the time, you can always power this access points or PDs separately, which means that there will be an adapter and you can actually connect this adapter here, and this can only be used as a data cable and this will be used for the power, right? Same thing here. So this is for the power and this is for the data only. But here, this is data plus power. Data plus PoE, this particular cable, right? Hopefully this is clear. I'm not going to explain how the traffic is actually moving out of it. We are only talking about the physical layer of the connectivity. I only showed one laptop because what I wanted to show you was in this configuration, this laptop will be connecting either to this access point or this laptop might be connecting to this access point, depending on the service set identifiers, SSIDs. So basically what happens is this starts shouting like a dog that, hey, you know what, I am access point 1, he will say I am access point 2, and whosoever barks more strongly, this laptop will actually catch that and will actually get connected to that in a very simplistic terms. So hopefully this is basically the beginning of the computer networks, the small home networks. Time Warner cable, there is a router provided by the AT&T. It sometimes also acts as a router and a wireless access point. So I just wanted to show you that this could be multiple switches, this could be multiple computers, this could be multiple access points on floor 1 and floor 2. You could have multiple laptops connecting over this Wi-Fi network. Some of them would be wired, some of them would be wireless. Your TV would be wireless. Maybe LG TVs come with Ethernet ports also. So it could be wired, could be wireless. So more and more devices are getting connected to the internet. So I think it's a very good startup point for you guys to understand that how to build up these networks using these technologies, what we just talked about. Hopefully we have covered a majority of the PoE, majority of the smaller networks, how they are actually built up. What is the function of RJ45, what is the straight over cable, what is the crossover cable, how does the PoE actually is transferred over alternate A configuration, alternate B configurations. We have specifically talked about TIA standards 568A, 568B, and a lot of other things which were covered. I'm not expecting you guys to understand everything in a moment, in a span of 1 hour. I would highly recommend to rewind these videos and try to understand. And I'm always here. If you guys don't understand a particular piece of it, you can always send me an email. You can always leave a comment, a feedback. Please do share this video with your families and friends. This will encourage me to actually put more videos for you guys. And this particular video series is only for C7 California low voltage certification exam. This is not a part of the exam, but I felt necessary because I was receiving a lot of queries from you guys that, hey, could you actually explain us what happens in the details when these technologies are basically used. So I will try to do more and more in the upcoming videos. Thanks once again for watching the video. That's my time. Thank you so much. Bye.